There you go.
Ah, nice. Okay.
There you go. Okay. We're on comets, which are on page 113. We may have finished comets.
Yeah, what if that was my plane. But with nothing to do with red.
Finish comment.
Nothing. You didn't know about lambs on the parking?
Talked about the tails. Here's a couple pictures. This is a picture from Halleys Comet. That's the one that comes around every 76 years?
Wait, so when's the next time it's going to come?
This is a good question.
What'd you say?
We decided on like.
1986 was when it came by, and it should be 76 years after that.
2063?
Is that 2063? I don't think so.
I think it's 26.
2062. How old will you be in 2062?
18.
I was one.
Also 18.
I will be
No. Wait, what?
94.
Good luck to
I
you.
may not make it.
No, you'll be there to see it. I know you will.
I may not make it. Here's what I want you to do. When you see Halleys Comet come by that year, I want you to think of me and wonder if I'm still alive.
I'll just call you. I'm sure.
Yeah, look me up. I'll be on Facebook. I'll probably have 10,000 friends by then.
We'll take you out of average for an extra few seconds.
Sure.
You can say, Mr. Willis, are you still alive? It's coming.
Don't forget.
That'll be my goal, to see Halleys Comet again. It's a little video of what it looks like inside the comet.
Nearing the sun, comets display violent activity. Gases boil off the comet nucleus, forming a coma surrounding it. Also, two tails form, an ion tail straight back and a dust tail lagging and curved.
This is not very good. Oh.
Up close, jets are seen on the sunward side of the evaporating nucleus.
Alright. That's enough of that. This is a comet. There was a mission called Stardust. And what NASA did is they flew a spaceship up to a comet. And I guess this is the nucleus of the comet. And the spaceship passed through the comet's coma, the big area of dust around the nucleus. And the spaceship had a material which looks like this. It's a real light material that it kind of stuck out of its side, held that material out, and a lot of the fragments from the comet got stuck in the material. And then what they did was they flew the spaceship back to Earth, and they ejected the thing that's holding that material and parachuted it down to Earth, so they have comet fragments that they studied. It was a really involved mission. You can imagine going out in space and trying to return something. And here's what the little pieces look like. Little fragments. These are little tiny microscopic fragments here. And that's the little trail they left as they entered that material. that they showed. And so anyway, so they have pieces of comets so they can check out what it was made of and that kind of thing. And this is one of the reasons we know a lot about what comets are. Isn't that a cool mission? It was called Stardust. This is a different mission where the, and this is shown at the beginning of the chapter. What they did here was they took a spacecraft and it shot a missile at an asteroid. Or is that a comet? It's either an asteroid or a comet. I thought it was an asteroid. Yeah, it's an asteroid. They shot the spacecraft shot a missile, it hit the asteroid, blew a bunch of material out of it. This is the explosion that the little impact made. The missile was like a probe, it was just a piece of metal that flew, hit it, made an explosion, and then the spacecraft measured all kinds of things, because when it explodes like that, you can kind of look at what comes out of it and get an idea of what the asteroid's made of. That was a pretty cool mission. I think they show it here. It was called Deep Impact. Yeah, that's also a movie, and I think it might be that one. Yeah. Deep Impact. It's about an asteroid hitting Earth. One of my rentals.
That's what would happen if Armageddon was made.
There's the little spacecraft, and there it launches its probe, fires it at the comet or the asteroid. It's got little jets on it to speed up and aim it in the right place. Got a camera on it too. Oh no, wait, that's the spacecraft that fired it. Okay, here we go. Here's the thing coming in. Bam.
That's not a very big explosion.
Pretty big. That's a big old crater. And then this thing kind of flies closer and looks at the damage, and they can see what it's made of from that. So there's a probe stuck in that thing now. Huh.
Is that ever going to be warped, or is it just going to stay there?
It'll stay there forever, until that asteroid hits something, which may never happen. So, where do comets come from? Well, there are two types of comets: short period comets or long period comets. Long period comets come from an area called the Oort Cloud, and short period comets come from an area called the Kuiper Belt. The Oort Cloud and the Kuiper Belt. So let me show you what that is. Here's the Kuiper Belt. Here's our solar system. And all these little dots are objects that are in the Kuiper Belt. It's like a belt that goes around our solar system. The Kuiper Belt lies more or less on the same plane as the solar system lies. But it's a little bit wider, so it's kind of like a belt that goes all the way around. Pluto is a Kuiper Belt object that's very large. And all short period comets come from the Kuiper Belt. These things can knock into one another and then fall into the sun. If they hit one another and slow down significantly, they'll fall in towards the sun, and then they'll go on an orbit that's like this. They'll fall in and then go around the sun and come back. And we call that a short period comet. And by short period, we mean that it might take 100 years or 76 years in the case of Halleys Comet to go in and come back, and go in and come back. It doesn't take an extremely long time. So all short period comets come from the Kuiper Belt. So out here, these are just a bunch of ice balls out here. bunch of comets. And every once in a while they'll dive in toward the sun. And only when they get near the sun do you see the tails of them. The long period comets come from a big area outside the Kuiper Belt called the Oort Cloud. The Oort Cloud is a three-dimensional thing that goes all the way around in a sphere around the whole solar system. And our solar system is in the very center. And this area right here is the Kuiper Belt. And the Oort Cloud is a big sphere outside the Kuiper Belt, filled with millions and millions of comets. And they're normally just on some type of weird orbit around the sun, orbiting very slowly. It might take a single comet 20 million years to go around once. They're going real slow. Some of them are traveling 30, 40 miles per hour. Like the speed you might drive in a car. Well, y'all don't drive. Old people drive. Just kind of on a real slow orbit around the sun. And sometimes, again, they knock into one another, and one will come diving in toward the sun and come around it and go back. We call that a long period comet because it would take a whole long time to come back again, on the order sometimes of thousands of years. That comet Hale-Bopp was a long period comet. It came from way out here. We'll never see it again in our lifetime. It just made an appearance and left. It'll come back eventually. So the Oort Cloud is filled. This area, the Oort Cloud, is so big that it's about half a light year from one side of the Oort Cloud to another. And this is a huge amount of area. 50,000 AUs. That's 50,000 times the distance from the Earth to the Sun. I mean, this is a big. And that describes this whole area describes the influence of our sun. There is nothing orbiting our sun outside the Oort Cloud. Our sun's gravity pulls this far. And outside of it, the gravity is so weak that from our sun that it doesn't really hold anything. There's a great book, if you like comets, that was written by my favorite author, Carl Sagan, and his wife, Anne Druyan. It's called Comet. It's a whole book about comets. You ever want to read it? It's right here. I got all of Carl Sagan's books. He's a good writer. He talks about what it would be like to be standing on a comet that falls into the sun.
You didn't burn up and freeze.
If he didn't burn up and freeze. All right, what's a meteoroid?
A tiny piece of rock.
A small piece of rock or dust in space. Do you remember how big it has to be a meteoroid? Smaller than a certain size.
100 meters.
Very nice. Do it, McLean. If it's smaller than 100 meters, it's called a meteoroid. Sometimes a meteoroid will plow into the Earth's atmosphere. And then it lights up and gets real bright. And we call it a shooting star. You ever seen one of those? It's when a little rock, smaller than 100 meters, it could be all the way down to the size of a grain of sand, hits the atmosphere, and if something the size of a grain of sand hits the atmosphere, it'll burn up. And you'll see it streak across the sky. It's real bright because it's going real fast. And so it's a meteoroid when it's just floating out there in space. It's a meteor when it burns up. And if it's so big that it makes it all the way to the ground and hits the ground, we call it a meteorite. So these are three words that are easy to confuse for kids and adults. Meteoroid if it's floating out in space, meteor if it comes burning in the atmosphere, and meteorite if it makes it all the way to the ground. Michael, you getting all of that?
Question.
Question?
No?
Thought somebody said question.
Oh, she said flush.
Bless you. Gotcha. Phew, there it goes. Of course, the ancients didn't know what this was, so they called it a shooting star. Some stars just sit there and others shoot across space. That's not true. It's actually in our atmosphere. But if you make a wish on it, that wish will come true. That's proven. There's Meteor Trails. Have you anyone here ever seen the show Meteorite Men? They're guys that carry around these real strong magnets, because most meteors have a lot of iron in them, and a magnet will pick them up. So they look for meteors, because if you find them, they're real valuable, you see, and you could sell them, make a lot of money. One little rock can be worth $2,000 or $3,000. So the whole show is them looking for these things. And if someone ever gets a good picture of a meteor, and they see, somebody took this picture, obviously. If there was someone else, like in the next town over, that also took a picture of it, they can take the two pictures and figure out by triangulation, if they know about where the pictures were taken from, where the meteor hit. Because often people say, I took this picture and then I heard this loud explosion. Well, that means the meteor might have hit somewhere for the boom. And so they try to track down these meteors. Have you ever heard of a meteor shower? So here's how a meteor shower works. Actually, I have a video that probably shows it the best. As a comet goes around the sun, it leaves a trail of dust particles. Remember, when it gets to the sun, it grows this big tail, which is particles from the comet. And those particles will kind of stretch out and move around and extend themselves through the entire orbit of the comet. And so you'll have all these particles just floating around in space that are following this curved path around the sun. And if the Earth moves through that curved path, all that debris will hit the Earth, and you'll have a whole bunch of meteors at the same time. That's a meteor shower. It's the Earth moving through a comet's tail, basically. Here we see, this is the Earth, and the Earth is orbiting about the sun. And this is the orbit of a comet. And every time it comes to the sun, it gets a tail, and it leaves a big trail of dust and debris. Eventually the comet will disappear. It'll lose all its material. And you'll just be left with material strung out all along this path. And if the Earth moves through that path, you get a meteor shower. A bunch of dust and debris hitting the atmosphere and burning up, and you can see a bunch of them. Now, a meteor shower doesn't just suddenly happen and it's over. It usually takes the Earth several days to move through this path. And so meteor showers have what we call the day of most activity, the highest activity day. There'll be like 3 days where you're seeing a lot of meteors, and there'll be the time of most activity when the Earth is right in the middle of it. And normally, it's not like there's 50 meteors flying at you at once. You'll see a meteor, and a minute later you'll see another one, and a minute later you'll see another one. They come about maybe once a minute or once every 2 or 3 minutes. There have been some that have been where they're flying at you like that, but that's very, very rare. This kind of shows it well.
When rounding the sun or a Jovian planet too closely, comets and asteroids can break into small fragments. If the debris intersects Earth's orbit, it can produce either delightful meteor showers, as is often the case with comet fragments, or catastrophic impacts, as is often the case with asteroid fragments. The animation, not done to scale, depicts mostly the latter phenomenon.
See, the Earth's kind of moving through this path. Oh, I missed it there.
Loser.
Dang it. Right here, it's going to hit it on the other side. Bam! Okay, so for a comet, let's forget about hitting asteroids. For a comet, there's lots of material all the time strung around here. So every year at the same time when the Earth comes around, it hits the material. So there is a meteor shower at the same day every year for this particular comet. And they have a chart in your book on the top of page 116 that shows the calendar for meteor showers. Here it is. What's today's date? September 20th. There's nothing now, but look at this. October 9th, the draconic meteor showers, up to 500 an hour can come from that. That's about 10 a minute. That's about 1 every 6 seconds. So go outside on October 9th and look at the sky and see if you see meteors. Yes, question?
And can we do an extra credit thing then?
On that day?
That'd be cool. And
Actually, you can't see them very well if it's a full moon, if the moon's out. So we have to check on that. But maybe. But you can see all these days. Just keep this book handy if you like seeing meteor showers. Once again, that's a cheap date. Take your date out there and watch the meteor shower. You don't have to buy a movie ticket. Meteor showers were one of the first bits of evidence that told scientists that the Earth was moving. Because meteor showers appear to come from a certain spot. It's like the meteors are flying this way, and that way, and that way, and that way, and this way. And they all appear to be coming from a spot. It's like if you're driving your car through a rainstorm. It appears the rain is hitting the windshield here, and some of the rain goes by that way, and some of the rain goes by that way, and some of the rain goes by up above you. It appears that all the rain is coming from a certain spot. And that's not true. The rain is coming straight down, but you're moving. The reason why it appears to come this way is because you're moving so fast. And the same thing was true with meteors. Meteors all seem to be coming from a point, and they're flying by like this. And some of the old scientists looked at that and said, hey, I think the Earth might be moving. Because you can't feel the Earth moving, but if you're seeing stuff flying by like that, maybe the Earth's moving, right? That was the first evidence that any of the ancient scientists, I mean, I'm talking about the ancient Greeks even noticed this, that maybe the Earth was moving. That's pretty cool. They were right, it is. And the radiant, that spot, shows you where to look in the sky to see where the comets are coming from. For instance, on October 9th, the radiant is Draco. That means the meteors should be coming from the Draco constellation, which is near due north. So kind of look to the north on October 9th, and you should see. Of course, they probably won't be flying by that fast, but sometimes they do. And that's because the Earth is moving in that direction toward that constellation on its journey around the sun. All right, let's talk a little bit more about impacts. If you have a large meteoroid, it can hit the Earth and leave a big crater, causing lots of damage. There's one out west, Colorado maybe, called the Barringer Meteor Crater. was a rock about 50 meters in length, that's about half a football field, that slammed into the ground about 20,000 years ago. Maybe it was 50,000 years ago. There weren't any people around in North America. There were probably some wild animals though that got vaporized. Here's the crater. It's still there. Look at that huge crater. To give you an idea of the size, that's the little road that goes to it. It's a big tourist attraction. I went to it when I was a kid. I was like 8 years old. There's me and my dad heading toward the crater.
So unhappy in Australia.
I'm happy.
You know, craters.
There's what they recovered from the meteor. That's what was left of a 50 meter. It's actually in a glass case, I think. That's what's left of a 50-meter rock. A rock the size of half a football field. That's all that's left. It's a big piece of iron. And that's what it caused. And that's a picture we took standing on the edge of it. If you walk all the way around it, it's like 2.5, 3 miles around. The whole crater is like almost a mile wide. And you can actually go down in the middle and, I don't know, walk around down there again.
If it rained enough, would that turn into a lake?
It could, but it's out there in the desert, so it doesn't rain.
Okay.
And that'll eventually fill in. The reason why we don't have these all over the surface of the planet is because erosion fills it in with dirt. You know, wind blows and brings in sand, and whenever it rains, some stuff washes down in the middle, even though it doesn't rain that much. And eventually this will fill up and disappear. It might take 2 million years for it to disappear, but it'll eventually disappear. So you don't see many craters on the Earth, but they're all over the moon because the moon doesn't have any weather. And anytime there's a crater made there, it never disappears. So 4.5 billion years worth of craters are there on the moon. They've never disappeared. But the ones on Earth fill in. There's some people standing out on go out on this little ledge and kind of look down over it. Unfortunately, when we went there, my dad never got a picture of me with the crater behind me. It kind of upsets me. I got onto that when I first started teaching this class. This is a big lake that's in the shape of a circle in Canada somewhere. I mean, it's huge. That's 30 kilometers. So this is about a 30 or 40 mile wide lake that goes around in a circle. It's an impact crater that has filled in kind of in the middle, but on the edges it's a lake. They didn't know that this was an impact crater until they saw it from a satellite. This is the Tunguska Blast. It was in Siberia in Russia in 1908. A big meteor came and it never reached the ground and exploded just above the ground. It knocked down trees. They reckon it was as big as a nuclear bomb going off, but luckily it was in the woods and they didn't have any people out there.
Our atmosphere protects us, but there is evidence of large impacts on Earth. There are about 70 huge craters found throughout the world. One of the most famous craters is in Arizona near Winslow. This crater is 3/4 of a mile across and was made within the past 50,000 years. The majority of the meteorite that made it was never found. Most of it disintegrated on impact to have been about us and made up of iron and nickel. The question may arise of being hit by a meteorite. It is felt that meteorites hit humans only once in 10,000 years. There is only one known person to have been hit by a meteorite. A woman in Alabama was bruised when a 9-pound meteorite tore through the roof of her house, hit a radio, and then hit her. This is an exhibit that has been on display in the Field Museum of Natural History in Chicago for years. It was the sequence of events that occurred in 1938 when a baseball-sized meteorite hit a garage. It went through the roof of the garage and continued through the roof of the Model T Ford garage at that time. It went through the steel roof and through the car seat and came to rest on the muffler under the car. On June 30th, 1908, in Russian Siberia, there was a tremendous explosion that left an entire forest flattened. The sound of the explosion was heard 600 miles away. 5 miles away, an entire herd of reindeer were killed. Scientists believe that the destruction was caused by a meteorite or comet that burned up as it went through the Earth's atmosphere. Fortunately, this happened far from a populated area.
I don't know why the audio is so screwed up there. Yeah, there's one person alive today that's been hit with a meteorite. What? How unlucky would that be? This is a computer graph of the impact in Tunguska, Siberia, showing these are all trees flattened out. Now here was where the explosion occurred, only it was above it, it was up in the air. These are some meteorites. Most of them are made, this is just to show you the size, most of them are made of mostly lead and nickel, heavy substances. And again, if asteroids and if these rocks floating around in space are mostly lead and nickel, and they came together to make our planet, then why is it the planet mostly lead and nickel? And the answer to that is, our planet is mostly lead and nickel. When all these asteroids hit to make the Earth and came together to make the Earth, it was so hot that the Earth was molten. And all the lead and nickel sunk to the middle. And so the center of our Earth is lead and nickel. And the outside of our Earth is rock, which is lighter than lead and nickel. So in this, there's rock and lead and nickel. And all the lead and nickel sunk to the middle of the Earth, all the heavy elements. And just rock is still on the outside of the Earth. You also find in meteorites often a lot of gold, other heavy elements like gold, platinum, silver, and most of that is also sunk to the middle of the Earth too. If you could get down to the middle of the Earth, there'd be huge amounts of gold, but you just can't get to it. It's too far away, too much pressure, too hot. You just can't get to it. But they have gold deposits on Earth in different places. Have you ever heard of a gold mine? Oh, that place is a gold mine. You know, you dig down there and there's a bunch of gold. Why is there a bunch of gold sitting there? Because that's where an asteroid impacted millions of years ago. And the Earth wasn't molten. So it stayed right there. So there's a bunch of gold there. You see what I'm saying? So there are gold deposits and lead and nickel deposits in various places around the Earth where asteroids hit later after the Earth cooled. There's me next to one of the biggest meteorites ever found in one piece in the Smithsonian Institution. That thing's got to be worth millions. I was looking around to try and run off with it, and this guy said, "Hey, I'll take your picture." And I was like, "Yo!" I was going to carry that thing out of there.
Did that woman in Alabama sell that asteroid?
I don't know. Probably.
Do
I don't
you
know.
know
I might want to keep it.
Would it have paid for her damage?
I'd have probably so, yeah. I mean, just a little one. It depends on what it's made of, but just a little rock is worth a couple $100. So something that big is probably worth thousands. This is the Murchison meteorite. It's a famous meteorite that came from Mars. And if you open it up and look inside of it, you see little particles that... Actually, no, the Murchison meteorite didn't come from Mars, I'm sorry. It just came from outer space. But you see little particles inside of it that are organic, that have organic molecules like proteins and such in them. So it makes scientists think that there is evolution of large organic molecules going on in space, which, of course, life is made of organic molecules. Oh, there's the lady, Ann Hodges, the only known human being ever hit by a meteorite. November 30th, 1954. There's her wound. There she is holding the rock.
She doesn't look very happy about it.
He's going, yeah, that thing fell from outer space. Cop's going, what am I doing here?
Arrest the meteorite.
Okay. So, you read 4.2, and I'm actually not going to be here tomorrow. I'm going to show you a video about the formation of the solar system tomorrow. And so for this weekend, you have to read 4.3 and 4.4 for homework. So you can turn off the video. I'm going to show you, start a video here that